Today we're going to talk about finding missing side lengths using trig. So first, we're going to practice and see if we can determine what trig function we will need to use for the following triangles. Looking at A here, I see that this is my reference angle, the 24, because it's the acute angle that's being measured in my triangle. If I look across from that 24, X is my opposite side, so I'm going to label that with an O. Across from this right angle is my hypotenuse, and the other side that makes up my reference angle is the adjacent side. Based on the labeling, I can now see that the X and the 19 are the two sides of that triangle that are labeled. Since O and A are labeled in that triangle, I'm going to think about my trig functions. So, ka, toa, and determine which function I'm going to use based on the sides that are labeled. Because I'm looking for an O and an A that are labeled, I'm going to be using the trig function that begins with the letter T, or the tangent function. Let's try B. So looking at B, 31 is my reference angle. Across from that is my opposite side. Across from my right angle is my hypotenuse. And again, the other side making up that reference angle is my adjacent side. So now when I look at the labeled sides, I see that H and A are the two sides that are labeled. Looking up at my acronym SOHCAHTOA, I can see that A and H are in ka, or whatever function starts with C, which is cosine. Let's look at the very last one now. For this last one, 55 is my reference angle. Here's the angle opposite that angle. Here's the hypotenuse, and here is the adjacent side. Because O and H are labeled in this diagram, I'm going to look for the function with O and H, so, and that S stands for the trig function sine. In chapter 1, we talked about if we know two sides of a right triangle, then we can find the third, and we can find that third using the Pythagorean theorem. But today we're going to learn that if we know one acute angle and one side of a right triangle, then we can use trig or trig functions to find the other missing side lengths. So I've listed our steps below. Here they are. We're going to use the acute angle, the known side, and the unknown side to determine which trig function to use. And we're going to label those with O, A, and H to help. So let's start with number 1. Here is my reference angle. Across is my opposite side. Across from my right angle is the hypotenuse, which means the other side is the adjacent. Looking at these labeled sides now, I see that O and A are the two sides that are labeled, which means that the function that I need to use is tangent. So I'm going to write my formula. The tangent of theta is equal to O over A. Now I'm going to substitute in tangent of my angle, theta is always an angle, is equal to the side that I labeled O over the side that's labeled A. There are two ways to solve this type of equation. I'm going to show you one for this one and then another one for the second one. My step 3 on this says we're going to use means extremes property to solve. So we're going to solve it that way first. To use the means extremes property, I would need to put the tangent of 28 over 1 to then cross multiply. 1 times x is x, and that would be equal to 32 times the tangent of 28. If you have your calculator, now is the time to take it out. And you're simply just going to type in your calculator 32 tangent 28. However, before you type that in, you should make sure that your calculator is in degree mode. You can see on my calculator right here, it says that I am in degree mode. But to double check, what you can do if you're not in degree mode is to click the mode button and then scroll down. It defaults to radian mode, so this would be highlighted in black. To select degree, you go over to the right and hit enter. Once you're in the correct mode, you should get an answer of 17.0147. And this doesn't say to round, but most of our problems will, so we're just going to round here, I guess, to the nearest tenth. Let's take a look at number 2. So for number 2 here, I have my reference angle 40 here on the right. Across from the 40 is the opposite side. Across from the right angle is the hypotenuse, and that leaves the adjacent side unlabeled. I can see that my opposite and my hypotenuse sides are the two that are labeled, which means that I'm going to need to use the trig function that starts with s, or the sine function, to set up my ratio. And now I just substitute in the values. The sine of 40 is equal to 16 over x. Now you could use the means extremes property like I just did before to solve, but I'm going to remind you that another way to solve an equation like this, to get rid of the fraction, would be to simply multiply by the denominator. Either way, you'll get the same answer. In this case, we need to multiply x by the sine of 40, and that would be equal to 16. To get x by itself, I need to get the sine of 40 away from it, and to do that, I would use division, inverse operations. Sine and 40 will never separate from one another. The sine of an angle is always together. You can't just divide by sine, you have to divide by the sine of an angle. It's simply a number in your calculator. So now in my calculator, I can type 16 divided by the sine of 40. If you want to be fancy, you can set it up as your alpha y equals, to make it look like a nice fraction, 16 over the sine of 40. But either way you do it, you will get the same answer as you see here, which is 24.8915. ... which rounded to the nearest tenth would be 24.9. Looking at example 3 now, here's my angle, opposite, hypotenuse, adjacent. Because A and H are labeled, I'm going to use the cosine function. Cosine of 64 should be equal to my 15 over x. I'm going to cross multiply for this one right now. One times 15 is 15. And that's equal to x times the cosine of 64. We usually always treat the cosine of 64 or the sine of 64, the sine of an angle, whatever it is, almost like an x or a y, and it goes behind the number. So like 3 times the cosine of 64 would be 3 times cosine of 64, x cosine 64. But again, this cosine and 64 always stay together. But now to get x by itself, I have to actually divide by the cosine of 64. And in your graphing calculator, if you divide by the cosine of 64, you can type 15 divided by cosine 64, and you should get 34.2175. Or to the nearest tenth, 34.2. And lastly, opposite, adjacent, hypotenuse. Pay attention because in this question, notice that my hypotenuse is on the bottom of that triangle. My O and A are labeled this time, which means that I need to use the tangent function. The tangent of theta is equal to O over A. Tangent of my angle is 19 over x. Again, for this one, I'm just going to multiply both sides by the denominator. X times the tangent of 33 is equal to 19. And I'm going to divide by the tangent of 33 to get x by itself. Let's see what that is. 19 divided by the tangent of 33. 29.2574, or about 29.3. We do have a word problem down here. And this is where you're going to see some real-world applications of trig. And trig is actually a very common thing to use, whether it's in construction or engineering. John needs to build a ramp to his front door. The height from the base of the door to the ground is 22 inches. In order for the ramp to be safe, it cannot be more than 36 degrees. How long will the ramp have to be to the nearest inch? So John's got a front door, and he needs a ramp up to it. The height, it says, from the base of the door to the ground is 22 inches. In order for the ramp to be safe, it cannot be more than 36 degrees. So the ramp itself is 36 degrees. How long will the ramp have to be? Because it's talking about the ramp itself, I'm looking for this. That is where x is. So I'm going to label O, H, and A. In this case, I'm going to use sine. The sine of 36 is equal to the opposite over the hypotenuse. Again, I'm just going to multiply that by the denominator. And then to get x by itself, divide by the sine of 36. And I found out that that ramp should be 37.4286 inches, or to the nearest inch, about 37 inches long.